When you're working with systems of linear equations, there are only three situations you're going to be coming across. You can have two lines that never intersect. It'll look something like this. And I'm going to draw some arrows like here. That means that they're parallel. They're never going to cross. So you can have parallel lines. That's one situation. The other one could be, you'll see just like a single line like this. If you see a single line, keep in mind a system means you're dealing with at least two lines, so two or more. But if you only see one, that just means that they're overlapping. So these lines overlap. The third situation would be if you have two lines that intersect at exactly one point. So pretty much these are intersecting at one point. So I'll highlight it in red so you can see that is located right here. And keep in mind that the overlapping lines means that it doesn't matter where you are. Any point I pick is on both lines at the same time because they overlap. So these are all intersecting points. There's more than one intersecting point. The vocab word for two lines that don't intersect and have no solutions, right, no intersection points, is called inconsistent. Overlapping lines, they intersect everywhere. Any point you pick is on both lines at the same time. This is called consistent dependent. And then the last case, two lines that intersect at exactly one point, are called consistent independent. And as a reminder, inconsistent means they don't intersect. If they don't intersect, that means that there is no solution, because remember, a solution means that they cross at some point. So if they don't cross, that means there's no solution. Consistent dependent intersects at every single point. No matter which point you pick, it's on both lines at the same time. So this has many solutions, or infinitely many solutions. Right, it's an infinite number of solutions because the lines go on forever. That's what the arrows indicate. They keep extending forever, which means you always have a point that intersects on both lines. So you always have one you can find. An infinite number of points you can find. And in the last case, is consistent independent. They intersect only at one point, which means this only has one solution. And as a little tip, there are some memory techniques, like if you get confused with the vocab word. One way I remember consistent independent is the word independent. Notice that the word independent has the letter I in it. That I reminds me of this right here, like I for independent. They intersect at one point, so that I in independent, the dot for the I reminds me that that's the intersection point of one. That's how I remember that one. And that's, because vocab words are easily forgettable. So if you do like a little memory trick like that, it helps trigger what it is the definition is. And then you can see we have consistent dependent and inconsistent. The prefix in means not. So these don't intersect. There's only one case where it doesn't intersect, and that's parallel lines. So the ones that is inconsistent, the ones that have no solution, is the inconsistent one, because there's only one that's inconsistent, and you can see the other two are consistent. The only difference between the other two is that one is dependent versus independent. And if you remember which one is the independent, you'll remember which one is the dependent, because independent has the one solution, because the I reminds me of that, and then the dependent has infinitely many solutions. So pretty much all you have to remember is inconsistent and independent. Because once you know the independent one, which is one solution, you'll know inconsistent. The prefix means not, means no solution. And then the remaining one will be consistent dependent. So that's just a little memory technique you can use if you get confused on the vocab words.